Hello everybody, welcome back. This is Jenness. We're going to do our fourth video now on basic geoprocessing and automation. The last three videos we've discussed general geoprocessing, just learning what the tools are. We've learned about environments and different ways that you can run the tools and different hierarchies that they work under. And then we talked about Model Builder, a way to string a bunch of tools together and run that entire model as a single tool. Now we're going to look at a quick look at Python. So Python is the programming language of choice in ArcGIS. Esri is really pushing this language. It is a good language, lets you automate a lot of things, and depending on how far you want to go into it, you can do a lot of really complex and powerful things with it. Now, just to be clear, we're not actually going to learn how to write Python in this class. You don't learn Python in an hour. My analogy is that it'd be like trying to learn French or German in an hour. It's just not going to happen. You have to spend time, probably at least a full semester, studying Python, learning the different ways it can be used, learning the theory of coding and the basic ways you structure code. If you do take the time, I really recommend it though. There are a few Esri virtual campus courses that kind of give you a good introduction to it, and then there's lots of books on it. I recommend that Zandbergen book on Python scripting. There's just lots of books out there in general. The Zandbergen's kind of nice because it targets ArcGIS in general, but there's a lot more out there. And we have classes here at NAU on it that could help you out. If you'd like to look up those Esri Virtual Campus courses, then just go to this link here and do a search for Python. You'll see lots of choices. As a student, you have access to everything on there except for the instructor-led courses. For example, that bottom left one in the image here, creating Python scripts for ArcGIS. You notice they charge $1,800 for it, and no surprise, you don't have access to that. But you have access to everything else. Python is a very popular general programming language. It's used all over the place and has been widely used in GIS. It's nice because there are lots of programming environments you can choose from. These are called Integrated Development Environments, or IDEs. And if you go to Google and you search for Python IDE, you'll see that there's lots of choices. A lot of people just use idle because that is installed with Python when you install ArcGIS on your computer, so it comes with it. But there's other ones available, and yeah, just to be clear, Python isn't like its own program where there's just something called Python that you run. I mean, there is, but most people do the programming in some other source, like idle. Some people use Visual Studio. There's lots of choices. By the way, in case you didn't catch the reference, Python is based on Monty Python. This programming environment called Idle, it's named after Eric Idle. Python people love this kind of stuff. Lots of little Monty Python puns and subtleties. So you gotta get used to that. Now it's nice because it's used in lots of software other than GIS. So if you learn it, you can use it in many of the more technical engineering and scientific software. Now it is also used in other GIS software other than ArcGIS. So if you learn it and you learn the concepts of GIS, then Python will still work for you really well, especially used in QGIS. So that's one of the more popular free GIS software packages. So if you learn Python, you will be good to go in there. But it's really popular in the STEM fields: engineering, science, math, technology. If you learn Python, you can take it lots of places. Now there is a strange quirk with ArcGIS and Python, and that's that Python a few years ago, maybe back in 2013 or 14, it split into two different versions. And for several years there was Python 2 and Python 3 both going side by side. It's not like Python 3 just came and took over and Python 2 is obsolete. No, that's not what happened. They were two separate tracks, and people worked in both and developed both, and each were growing. Now, as of January of 2020, Python 2 finally reached end of life and it's not being developed anymore. So Python 3 is really the future of Python. Now most of ArcGIS desktop and server, that uses Python 2. So if you're going to be using ArcMap or ArcCatalog and want to use Python, you're going to use Python version 2. If you're into ArcGIS Pro, and this is the future of Esri's software, then that uses Python 3. So they're not that different actually. There are some important differences where if you write a script in Python 2, there's a fair chance it'll need some minor editing before it'll work in Python 3. So there's some changes, but if you've learned one, then you will be able to transition to the other. Now in ArcGIS Desktop, Python is usually used as a scripting language. This kind of sets it apart from a language where you develop actual custom tools. In ArcGIS, you use it more to run existing tools rather than create new ones. So Esri provides all those tools in the toolbox. Well, you can access all of those tools in Python. And if you look here in this window, you'll see the buffer tool. This is the top window. When you click the buffer tool, this is what you see. You see the different parameters you have to set. This should be pretty familiar. Well, when you run the buffer tool in Python, you set all those exact same parameters. You just have to learn how to phrase them and how to put them in quotes and where to put the commas. But it's basically the exact same thing. To get to the Python window, just hit the Python button right there at the top of ArcMap. It opens up the Python command line window. This is what Esri provides right in the software to write Python code. I told you that Python has lots of IDEs available. This is one. This is the one that you can use directly in ArcGIS. You can also write Python in the field calculator tool. So you guys have used this tool before. You write values to attribute fields in a feature class, and you use the field calculate window. Well, this is that window. Thing is, you can actually write code into that function. And I've got a model for you to play with if you like. And in that model, I do have several examples of writing Python code right in this window. So we'll show you that in a little bit here. Now, the Python language and programming rules are too much to cover in this class. This is what I meant by you're not going to learn how to write Python in an hour. But if you ever want to be the wizard of GIS and have everybody come to you for help, I recommend you learn Python or some other programming language. GIS just takes flight once you can program it. You can do so much more than you can just by clicking on the buttons. It's amazing how much you can do. Now, the fact that you won't learn how to write Python in this code isn't going to block you from using it, though. You can actually use Python without knowing how to write it because of something Esri has done with the tools. When you run a tool, the tools create snippets of Python code, and these are actually pretty easy to modify. So this is how you get to it. You go to the Geoprocessing menu and you open up the results window. The results window will show you the tools that you've run recently. You pick one of those tools, you right-click on it, do copy as Python snippet, and it gets copied right into the computer memory. So this leads to a common strategy people have, and this is something I do a lot. If I have to run a tool many times on and maybe with very slight variations on each run of the tool, I might just run it once by clicking on the tool and running it through there. And then I will copy the Python code out of that, and I will just paste it into like a text editor, and copy and paste it many times, as many as I need to, and then I'll make those slight modifications to the tool in those lines of code. Then I'll paste all those lines of code back into the Python window, hit go, come back in an hour or so when it's done, and it's a great way to run a whole bunch of tools. Now let me show you a quick demonstration of this idea. If you remember back a video or two back, we were looking at how to clip out a raster to a small area, and I showed you how to set the snapping environment so that the clipped raster would properly align. Well, we were using this climate data, this prism climate data. We were wanting to trim it down to the coconino, and so we did that. We just ran our little tool, we extracted the raster, so now our climate raster is just within the coconino, a much smaller data set, easier to work with, and generally faster and cleaner. So suppose we have a lot of these climate rasters, and if you're working with prism data, you usually do. And this particular data set is a monthly temperature mean, and they got temperature means back to the 1890s. And so when you have like 130 years of monthly data, that's well over 1,000 data sets. And maybe you want to do that same function with all 1,000 rasters. Well, you're not going to run a tool 1,000 times, or at least you're not going to do it and be happy. So this is an opportunity to run the tool one time, get some Python code out of that, and then just work out of the Python window. So let's take a look at that. The tool we did was extract by mask. We ran the tool, we put in our raster. We told we wanted to extract it to the Coconino National Forest. We pick a location to save it. I'm going to call it Coconino Temperature. Now this one happens to be 2014-01, which means January 2014. Okay, we'll just call it that. Hit go. It goes to work. Fortunately, it doesn't take a long time to run. Well, now we've successfully run the tool one time. That's fine. Now, what about these other rasters? Do I want to run the tool 5 more times or 1,000 more times if I wanted to do it on all of them? Now let's take a look at this. We want to go to the results window. You can get to it through the geoprocessing menu, go to results. It takes you to this results window. Here you can look at the tools you've just run. So I've just run extract by mask. This results is kind of nice. I could actually double click on this and open up the tool the exact way I had it set. I do this a lot when I can't remember where I saved a data set, or if I can't remember what parameters I used. I can just double click on this tool in the results window and I can see how I had it set up. So it's a neat place here. Now instead we're going to right click on the tool and go to copy as Python snippet. When we did that, it got copied to the computer memory, so it's sitting there ready, waiting to paste into something. So I open up another program. I'm going to use a text editor Notepad because it's really simple and works well for this. I have Notepad open. I just hit Control V to paste, or I could right click and do paste. This is the Python snippet that got copied. Now Python, when you have a number sign, that means that these two lines are commented out. It means Python won't pay any attention to them. They're just notes to you as you write the code. It's this line here that is the actual Python code that runs that extract tool. If we look at it closely, we can see our input parameters. This is the input raster that we chose, 2014 January. This is the new clipped raster that we created. So if I want to rerun this on those other rasters, I just copy that line and paste it a few times. I change a few values. I'm going to do February, March, April, May, and June. So now I've selected the rasters I'm going to clip. Now I have to set the names of the rasters I'm going to save. All right. So now I have 5 lines of code based on that initial line of code. I just copy that. I selected right click, copy, come back to ArcGIS, open up my little Python window. Python's window, I just paste it in there. And these are all those lines of code that I just copied. It's all ready to go. I just hit enter and it goes to work. And it runs that same tool on all of those new rasters. Now if I'm doing it on 1,000 rasters, I have found a good time to go to lunch. Now since I'm just doing it on 5 rasters, it's not going to take very long. And there we go. It's all done. So I ran the tool once, used it to extract the Python code. Then I was able to copy that Python code in a text editor, make minor changes, copy the whole batch out, paste it into the Python window, and it did everything. So this is a neat way to make use of those snippets. You can also get some good Python sample code out of the help windows. If you go to any of those help windows and scroll down toward the bottom, you'll see these code samples, and the code is always in Python. So there's some good stuff to get out of there as well. Now, in that demo I just showed you, I use Notepad to copy and paste and make my edits, and I really like Notepad for that. But be very careful never to use Word or WordPad. You're kind of used to writing in Word probably, so it seems like a reasonable place to do it. But it turns out when you write in Word, and if you put quotation marks or apostrophes, Word changes them to make them into these curved apostrophes or slanted quotation marks. It makes it look better visually, but it actually changes the character. That those slanted quotation marks are not the same quotation marks that Python is expecting. So Python will read that as a bug. So if you do put it in Word, you start changing things around, all of a sudden you've corrupted your code because it puts in those slanted things. So stick with something simple like Notepad. Notepad's really good for editing Python code. Now this is not necessary, you don't really have to go into it, but if you are interested, recently a student asked me for some help with some stuff, and in order to help him, I made a model using Model Builder, and in the model I had lots of tools, and lots of those tools used Python code in them. So this model is a demonstration or just a sample of how you can use a model, how you can use the calculator window in that model, and have Python code within a calculator window. So lots of little examples in there. Now the thing you wanted to do is actually kind of tricky. You wanted to have a polyline that was draped over a DEM, so draped over the elevation, and he wanted to calculate the slope at regular intervals along that line. Now this wasn't the slope of the landscape. This was the slope of the line as it traversed the landscape. So it'd be sort of like if you put a trail along the edge of the Grand Canyon, the trail took you down into the canyon. Well, the canyon itself is very, very steep, but the trail is not. So this is like calculating the slope of the trail. And so in order to do this, I made him a model that would do several things in order. First, it would intersect his polylines with the DEM surface, and it would create these polyline Z features that have elevations written into them. And it would create vertices every 30 meters. And for each of those vertices, it would turn it into a point, and then it would add attribute fields for latitude, longitude, elevation, vertical and horizontal distance from the previous point, and the slope from the previous point. And then it would calculate values for all of these fields using Python code, and that Python code was embedded in that calculate field tools. So if you're interested and want to see an interesting example, this is what it would do. You draw that red line, hit go on the tool would create the points, and for every point it would give you the coordinates, the elevation, the slope, and the horizontal distance traveled. That's kind of neat. And here's a picture of that model and actually we looked at this model earlier when we were demonstrating the auto layout tool. If you open up the model for editing, and it looks a little like this, you could go to one of those calculate field tools and just double click on it to open it up to see how it's set up. Notice that it has this code block, and this is all the Python code that gets written into the calculate field window. It runs all this for every one of those, for every one of the points it generates, and each one of these calculate field functions has a different set of code in here. So there's just an example of how you can put Python code right into a calculate function. Well, that's about what I have to say about geoprocessing, model building, environments, and Python in general. So why don't you go ahead and start in on those labs, and just give me a holler if you have any questions. Thanks so much.